Descriptive geometry is like a superpower. It helps you visualize and draw three-dimensional objects on a flat surface. It's like magic, but with more math. Architects, engineers, and designers use descriptive geometry every day. They use it to create blueprints, design buildings, and even make video games. Imagine trying to build a house without a blueprint. That's where descriptive geometry comes in. It's the language of design. In this crash course, we'll explore the exciting world of prisms, areas, and composite figures. Get ready to level up your spatial reasoning skills. Prisms are everywhere, from cereal boxes to skyscrapers. They are a fundamental part of our daily lives, often unnoticed but always present. These three-dimensional shapes are not just confined to the realm of mathematics. They are integral to architecture, design, and even art. But how do we draw them accurately? That's where true magnitude comes in. Understanding the dimensions and proportions is key to creating a precise representation. Whether you're an architect designing a building or a student learning geometry, mastering this skill is essential. Step 1. Imagine a prism as a stack of identical shapes. This shape is the base of the prism. Visualizing this can help you understand the structure better. Think of it as stacking layers of the same shape on top of each other. Step 2. Draw the base shape on your paper. This is your front view. Make sure to use a ruler for straight lines and accurate measurements. This base will guide the rest of your drawing. Step 3. Now draw lines straight up from each corner of the base. These lines represent the height of the prism. The height is crucial as it gives the prism its three-dimensional form. Ensure these lines are parallel and equal in length. Step 4. Connect the tops of the lines to form the top face of the prism. Boom! You've drawn a prism. This top face should be identical to the base shape, completing the three-dimensional figure. Exercise. Try drawing a triangular prism using these steps. Remember, the base is a triangle. Practice with different shapes to get comfortable with the process. The more you practice, the better you'll get at visualizing and drawing these fascinating structures. The area is the amount of space inside a two-dimensional shape. It's a fundamental concept in geometry that helps us understand the size of different shapes. Whether it's a simple square or a complex polygon, knowing how to calculate the area is essential. To find the area of a plane in a three-dimensional object, we need to find its true magnitude. This involves understanding the plane's orientation and how it fits within the 3D space. Think of it like flattening a box. You unfold it to see the true size of each side. By laying it flat, you can measure each face accurately. This analogy helps us grasp the concept of finding the true area of a plane. We can do the same with planes in descriptive geometry. Descriptive geometry allows us to visualize and solve problems involving the true size and shape of planes. Method. We use projection techniques to rotate a plane until it's parallel to the projection plane. This method ensures that we can see the plane in its true form without any distortion. This gives us the true size and shape of the plane. Once we have this, calculating the area becomes straightforward. Example, imagine a slanted roof. The slant makes it tricky to measure directly. To find the area, we project it onto a horizontal plane. This projection simplifies the complex shape into a more manageable form. Now we can easily calculate the area using basic geometry. By breaking down complex shapes into simpler ones, we can apply basic formulas to find the area accurately. Section 4, Mastering Composite Figures, a Building Blocks Approach. In this section, we delve into the fascinating world of composite figures, which are essential in both architecture and engineering. Composite figures are like Legos. Just as you can create complex structures by combining simple Lego bricks, you can build intricate shapes by combining basic geometric forms. They're made by combining basic shapes. These shapes can be as simple as cubes, spheres, and cylinders, but when put together, they form something much more complex and functional. This makes them easy to build and analyze in descriptive geometry. By understanding the basic components, we can simplify the process of designing, and constructing more complicated structures. The process is simple. We break down a complex figure into simpler shapes like cubes, pyramids, and cylinders. This method allows us to tackle even the most daunting designs with confidence. Then we use true magnitude to find the area and volume of each part. Accurate calculations are crucial for ensuring that each component fits perfectly within the overall design. Imagine a house as an exercise. It's a composite figure. By visualizing a house in terms of its geometric parts, we can better understand its structure and design. The main part might be a cube, the roof a prism, and the chimney a cylinder. Each of these shapes contributes to the overall form and function of the house. By understanding each part, we can understand the whole. This holistic approach allows architects and engineers to create more efficient and aesthetically pleasing designs. This is the power of composite figures. They enable us to break down complexity into manageable parts, making the design and construction process more intuitive and effective. Section 5: Practical Applications, Descriptive Geometry in Action. Descriptive geometry isn't just for math class, it's a powerful tool used in many fields. Architects use it to design buildings, bridges, and other structures. They can accurately represent complex designs on paper. Engineers use it to visualize and analyze machine parts, create technical drawings, and solve design problems. Even video game designers use it to create realistic three-dimensional environments and characters. Descriptive geometry is all around us, even if we don't see it. Section 6. Exercise putting your skills to the test. Ready for a challenge? Let's design a dream treehouse. First, sketch your treehouse idea. Don't worry about being perfect. Next, identify the basic shapes that make up your treehouse. Then use the steps we learned to draw each shape in descriptive geometry. Finally, calculate the area of the floor and walls to figure out how much material you need. Congratulations, you've just used descriptive geometry to design your dream treehouse. Section 7. Conclusion: level up your spatial reasoning skills. Mastering descriptive geometry is like unlocking a new level of spatial awareness. You'll be able to visualize and manipulate three-dimensional objects in your mind. Remember, practice makes perfect. Keep experimenting with shapes, areas, and composite figures. Who knows, you might even design the next architectural masterpiece.